Hello, this is my PHYS project. In this project, the purpose is to learn more about RLT circuits and their behavior when we change the frequency and learn the key concept of resonance frequency. Now, let's start by methodology. First, as shown in the video, we start off by building our circuit. This is a 10 ohm resistor, 100 micro henries inductor and a 1 microfarad of capacitor. And as you can see, the power source is plugged in to a signal generator that's outputting a 5 voltages of a signal with the frequency of our choice. I mean, in this case, it's a 500 hertz frequency. Then, as you can see in the image video, we plug it to oscilloscope. We plug the resistor into oscilloscope, and we measure and display the waveform onto the oscilloscope display. Now we are ready to do our first step. Our first step is calculating the phase shift. To do that, we are connecting two oscilloscope probes in our circuit, one for the whole circuit and one for just for the resistor. Then we display it so that they are overlapping each other to see the phase shift better. And as you can see, the green one is for the resistor and the yellow one is for the whole circuit. And as you can see, there's a small shift which I indicated with the cursors that we calculated as 1.44 milliseconds. And when we do a ratio, the equation is going to be on the screen. We can see that the corresponding angle is this angle. So now that we can do the table 1, now on to table 2. For the table 2, we have to find our resonance frequency, and to achieve that, we slowly change the frequency of the signal to achieve the peak, the max voltage that we can achieve. And as you can see from the video, this is the circuit. Then I slowly input a different frequency, and as you can see, there's a different voltage that is measured. I do this for different sample points, and I found this value of frequency. Now we can compare it to our theoretical value and have a percentage error of this. Now for the conclusion, I think we can safely say that our experiment was a success because we observed our expected behavior. First, in the phase calculation step, we calculate the rather close phase shift, and although there was some error, that's maybe because of a misplaced cursor, because we just manually placed it and there could be some human error in it. I think we calculated pretty close. Also for the resonance frequency, again there is expected behavior. When we plot it on a scatter plot, we can see a bell-shaped curve around the frequency to be called resonance frequency, which is expected. Also in that experiment there was a small error, and I think that can be mostly because of I couldn't give really exact frequency values from the signal generator, and that maybe caused some small errors. But at the end of the experiment, we learned that different frequencies result in different phase shifts, as well as resonance frequency, the current is at max. Thank you for listening to my Physics 102 project.